Hey everyone, we're going to talk about the difference between degrees and what's called radians. So we're super familiar with a degree being some kind of measure between an angle. So like if I gave you a triangle and I say, go measure that, you would say it's 130 degrees. All a degree tells us is using the same protractor, using the same triangle, we could all measure and figure out what that is. And it's super useful for construction and stuff like that. But for math, that's the end of its application. So let's pretend that we are standing on a horizon. We're watching the sun rise and then come above us. So this sun started here and is here, and we can find the degrees. And that would be the end of its application. However, what if we said we wanted to measure this arc length? Degrees can't help us. What can is called radians. What radians does is it converts degrees into a measure of curves. Okay? Degrees can only say, here's a straight line, this is the movement. Radians can measure this curvature. So to use it, let's say they give us a degree and we want to convert it into radians. Let's say they gave us 90 degrees. What we would do is we would multiply by 180 degrees, because ancient Greeks, looking at the sunset, it was 180 degrees until the sun set. That's why we do it this way. Pi is on top because we're talking about eventually a circle because it's curved. And we'd say radians. Okay? So then I would have 90 pi over 180. Then I would be able to cross out the degrees. And then 90 over 180 reduces to 1/2. And what's cool about radians is, yes, the radians is here, but we don't have to write it again. So this would be my final answer. 90 degrees is the same as pi over 2. Then the flip side is if they asked us to go from radians to degrees, so let's say I had -3 pi radians over 4, we would multiply by the opposite. So 180 over pi radiant. The pi's would cancel, the radians would cancel, and then I multiply across, I would get -540 degrees over 4, which reduces down to -135. How do we have a negative degree? So how that works is our sun, when it's rising and falling, that's going from east to west, and that's a positive thing. We can measure time. If it's going the opposite direction, so we're going backwards in time, this is where I get my -135 from. Okay? And the last thing that we can do is find our arc length using radians. So let's say that the sun is all the way to here, and so our measure is 120 degrees. What we can do is convert that to radians by multiplying by pi over 180. The degrees would cancel, and then I'd get 120 pi over 180, and that reduces down to 2 pi over 3. Our arc length calculator is S stands for arc length, R stands for radius, and then theta. Theta just means the measure of an angle. So, the measure of our angle is 2 pi over 3. And let's say the radius, we measured the sun somehow from the highest point down was 10 miles. So we would say 10 miles. So then we would get 20 pi over 3. I plug that into my calculator. 20 times pi divided by 3 and I said 20.94 miles. So what does that mean? So this curve, if we were to have taken that curve and then pulled it straight and said, how far did the sun move from down here all the way to over here? The sun moved 20.94 miles.